In this lesson, we're going to be taking a look at 1.3, solving linear equations. If you take a look up here, we have three objectives. Translate verbal expressions into algebraic expressions and equations. Number two, identify properties of equality. And then number three, solving equations using those properties. So if you take a look at number one, we're looking at translations from more English words, like all these over here on the left and right. And there's more than just these. And hopefully convert those into more algebraic type of expressions. And so some of the key words is like plus, and a lot of these you already know: addition, subtract, means subtraction, times, multiplication, divide is division, of course. Sum is the result. So when you see the sum or the sum, we're talking about an addition problem, the result of an addition problem. But I like putting the bubbles there because the sum is the result of an addition problem, not just that we're adding. Difference would be the result of a subtraction problem. So again, I like the bubbles to help us. So if we had something, and we'll take a look over here, but we have 5 times the sum, this is going to be 5 times the bubble. So we'll talk about that in a moment. But twice means 2 times something. Equals, obviously we know that. Is also equal, so you can see that over here on the right column. Squared is taking something and multiplying it times itself. So we usually put a little 2 up there. Cubed is taking something and multiplying it times itself 3 times. Now we have a little 3. Increased is addition. Decrease is subtraction. Is, we've already taken a look at. Less is subtraction. Now this less than, and this is one that you want to note here, this one less than is going to be very important for us. Less than is tricky because we see the word less and we think subtraction, which is true. It is subtraction. But the word than actually flips the order that you read it. And so we have less, subtraction, than, and if you think about it, it makes a lot of sense. If I say, what number is 5 less than 10? So 5 less than 10. If you take a look at that, it looks like a lot of students want to put 5 minus 10 because it's 5 less and then the 10. However, that's not going to be right in this case because we have the word than there. And so what number is 5 less than 10? Well, it's 5. Well, how do we get that? It's 10 minus 5. You see how the order changes. So keep that in mind. That one's a little tricky at times. We want to make sure that we don't fall into that trap. If you look at our examples over here, we have the first one, 5 times the sum of 9 and a number. And we talked about that. First off, just identify 5. Obviously, it's 5. Times, we're multiplying, so I'll put a dot there, or you can put an X if you want, but I'll put a dot for multiplication. And then notice it says the sum. Okay, so notice that what that is we're multiplying 5 times what? The sum. So we're multiplying it times a bubble. A bubble of what? That's going to tell us next. So we have 5 times what? The sum of what? Of 9 and a number. And so we have 9 and a number. And a lot of students will write that without the dot in, and that's perfectly fine. It's something like this. And there's your conversion from a verbal expression into an algebraic expression. The second one, 3 less twice. Why? Notice the word less, and we have obviously 3. Less means subtraction. There is no than, so the order that I wrote it in is the order that we're going to put it. So 3 less twice is 2 times, in this case, y. 8 less than 5 times the number. So here we go. We have 8, but we have less than, and this is going to flip the order that we see it. Now, what are we subtracting here? This is obviously meaning subtraction. What are we subtracting? Well, 5 times a number. So 5 times some number, and a number is a variable. We'll use X, you can use Y, or whatever you want, some variable of some sort. That represents a number. So we have 5 times a number, and then subtract the 8. Notice the order that we read it is the opposite of the order that we wrote it because of the than. So be careful of that. That does get a little tricky for some students. Okay, moving on, we're going to be taking a look at some properties now. And all these things, what we're going to be doing with properties, we're going to be applying to the equations. And so what we have is we have reflexive. This is probably the one that's the easiest to remember, and that just says for any real number A equals A. So that's pretty easy. We won't come across that one a whole lot. Substitution, what you'll find there is with substitution, you're replacing something with an equal value. So if A equals B, then A may be replaced by B. Or B may be replaced by A. So if you look over here, we have if 4 plus 5 times m equals 18, then 9m equals 18. Well, what allowed us to go from 4 plus 5 to 9? Well, we simply replaced 4 plus 5 with 9. That's what we did. It's a substitution or a replacement. Okay, the third property of equality is symmetric. Now, symmetric and transitive are the two that we want to be careful of because, we definitely get in the habit of confusing these two. And so I'll put a star next to those, making sure that we understand those two, not because they're any more important than these two, but because they do get confusing to some of our students. It says if A equals B, then B equals A. Notice that with symmetric, we're comparing two things. Okay, so keep that in mind as we're comparing two things instead of 3. It's a shorter, okay? We're only comparing 2, not very many things. Okay, the transitive is the much longer of the two. That's a train. You can think train is a little bit longer. We're comparing 3 things in this case. So if you're comparing 3 things, then you're talking more transitive. So if A equals B and B, so it has this word and in there, and B equals C, then A equals C. And so A goes all the way to C. The last two we'll take a look at is what I'm going to refer to a lot of times as cancellation properties. In Algebra 2, a lot of times they're called the addition or subtraction property of equality or the multiplication division property of equality. And so the addition subtraction property of equality simply says if A equals B, then A plus C equals B plus C. Or you can do subtraction as well and say A minus C is equal to B minus C. So that's where they both come into play. Multiplication division, very similar. It just simply says, look, if you have an equation A equals B and you multiply A times C, then you better multiply B times C. Or division, if you divide A by C, then you've got to divide B by C. And so that's called the division property of equality or multiplication property of equality. In college algebra, they call it the cancellation properties. And so that's why a lot of times we'll go ahead and expose it to you now. The way to remember this one, you can see I have a star around this. What do you do to one side of the equation? You must do the other. Most of you already know that, but there's a property that allows us to do that, and that's key in math. Is anytime you do something in math, it better be backed by a property. In this case, we got the cancellation properties that say, let's keep these equations balanced by simply doing whatever you do to one side, you got to do the other. Now, let's do some practice with these properties and see how we can do, or how we're doing on memorizing those. It'll take a little while, but repetition is going to come into play here with properties. So if we look at the first one, it says if 2x equals 3d and 3d equals -4, then 2x equals -4. So notice it's an if-then, but it has the word and in there, and that sort of gives some things away. But notice what we're doing is we're comparing this 2x, we'll call it A, to 3d, which is B. And there's your B again. And this is a new one, so it's C. So notice we're comparing 3 things, an A, a B, and a C. And then we say A equals C. This is that transitive property. Okay, and I'm going to abbreviate it there. Okay, so transitive property of equality. Second one, if a 5 plus B equals 13, then B equals 8. Well, how in the world did I go from here to there? Well, I would hope that you notice that we subtracted 5. And whatever you do to one side, you do the other. Now, catch yourself saying what I just said. Whatever you do to one side, you got to do to the other, because that gives it away what property we're talking about here. This is the cancellation property. Okay? Specifically, we're adding a -5. Right? Or you can say subtraction property of equality, and that would be fine as well. Okay? So cancellation, what are we adding? A -5 is what we're adding, or we're subtracting 5, same thing. Taking a look at the third one, if 3 times -2 times z equals 24, then -6z equals 24. If we take a look at this one, notice what we've done is we simply replaced that with this. Because 3 times -2 is -6, this is a replacing, this is substitution. Okay, that's what we have there, substitution. Taking a look at the last one here, we have if 5x equals 10, then 10 equals 5x. Notice what I'm doing is comparing 2 things, A and B and A. Now there's your symmetric property. Okay? And so we're comparing 2 things. All right. Now we're going to take these properties and actually apply those when it comes to solving equations. And if you don't want to forget what your ultimate goal is when you're solving equations, and your ultimate goal of solving equations is really to find what value would you have to plug in for all these unknowns to make the equation true, to satisfy the condition. And so how do we do that? Well, we want to isolate the unknown, or the variable. Now, what's this mean about isolation? We want to get it by itself. So how do we do that is really the process here. Well, the first thing we want to do is we always want to try to expand. Now, when I say expand, that means get rid of parentheses. So distribute, like down here. We're going to distribute 4. We'll talk about this one as key, distributing -3, and so on. So getting rid of your parentheses. And then we want to combine like terms, which means if they're on the same side, we want to go ahead and get those together. And we'll have that issue down here. So we'll use the first process mainly on that 4th example. Then we're going to move the constants to one side. It doesn't matter which ones you do first or second here, but moving. You're going to be moving constants, put all the constants together. The constants are the values that don't have a variable attached to them. And then you're also going to move all the variables, which are usually the letters here, all on one side. So they're going to be opposite of each other. All the variables on one side, all the constants on the other. Whenever we're involved with moving, we're talking about addition and subtraction. We're undoing it through the inverse property of addition. And so here, if I want to undo a -5, a subtraction of 5, the opposite of that would be adding 5. That's the property we're using. And I'm moving my constants over to the other side. Now, our variables are already on the opposite side as our constants, so we're in great shape. Now what we want to do is undo, inverse, remember that from earlier sections, invert the coefficient by multiplying or dividing. So undo, we're going to be using multiplication or division. So when I want to undo through multiplication, my objective is not to get 0 like it was with adding and subtracting, but it's to get 1. And so we're going to go ahead and divide by 2. That allows it to be 1a. Because I don't care what 2a is, I want to know what 1a is. And same with you. And so we get this answer of 12 divided by 2, which is 6. And then keep in mind with equations, man, the best students always check their answers. This is real easy to plug in. 12 minus 5 is 7. Very good, you got the right answer. So definitely take the time to check it if you have that opportunity. Moving on, let's take a look at the one down here. It's a fraction. We always get intimidated by it. Don't be intimidated by fractions, just work them. Okay, but what we want to do is we want to get this by itself. That's our goal. So anything attached to it, we'll wait. What we want to do first is we want to move the constant. So moving this 1 by undoing an addition of 1. We're undoing things, in this case to move, and to get this to be a 1. My next objective, again, my goal is to get n by itself. For some of you, maybe putting a box around what you're trying to get by itself is a good thing. Now this is where you have some choices. A lot of students will multiply both sides times 4, and they end up getting -3n equals -48, because the 4's would end up canceling. And then they would divide by -3, and they would end up getting 16 as their answer. Okay. Another way to do this is to really, our goal is to make -3/4 1. So why don't we multiply by -4/3? It's the reciprocal. Okay, and so the negative times negative is positive, and the 4's cancel, and the 3's cancel, and we're left with just n. That's why we do it. Over here, we multiply by -4/3. 2 negatives make a positive, and if you notice here, the 3 and the 12, I always like to cancel, go to there, and then what you'll notice is you get a positive 16. You get the same answer no matter which way you do it. So however you visualize it, I would love it to where you guys know both ways of doing it. So if you had to pick one or the other, you could do that. Okay, let's go ahead and take a look at this third example. And notice the difference on this one is we have variables on both sides and we have constants on both sides. Now, it doesn't matter which side you move the variables. I could subtract 2b over here. But I'm actually going to move my 3b by undoing the subtraction of 3b by adding 3b. Now, the reason I'm doing that is because I like to keep my variables positive. And so notice that it's a positive 5b. So I kept my coefficient of my variable positive. Now I'm going to go ahead and add 15. You could have done that maybe in the first step as well. And again, don't freak out at this point. Hopefully you get to this point. And once you do, to undo the 5, we divide by 5. And I say don't freak out because we do have a fraction here, 22 over 5. And we just want to leave it 22 over 5. Don't put it as a decimal. Don't put it as a mixed fraction. Leave it improper. Mathematically, it makes it a lot more convenient for us to manipulate our information with improper. Do reduce the fraction if you can. In this case, we can. But you can still check it. I know most students don't like plugging that back in. It looks really bad. But you definitely can, and you can see it right here, is if I plug it in here, the 5's would cancel. I get 22. Negative 15 plus 22 is 7. So as long as I did my moving right, I'm in good shape. The last one, which I have a star next to, so note that. this is the one that you're definitely going to have some work on in the test, so make sure you know how to do this one. But first thing we got to do is expand, all right? We got to get rid of our parentheses, so we go ahead and multiply and distribute the 4. There's your distributive property that we've talked about. The key is right here. Here it is. Here is the tripping point. This is what is going to keep some students from being successful on these problems, is what are we distributing through this quantity? It's not a 3, it's a negative 3. Okay? That subtraction sign's tied to that coefficient right there. And so we need to make sure that we recognize that and we distribute that value through. And now at this point, we're in pretty good shape. Most of the mistakes happen right before that. If you make it here, you're in pretty good shape. Let's combine like terms though. 4q minus 3q. They're on the same side, so I don't need to move them. I just need to combine like terms. Well, if you have 4 bananas and you take away 3 bananas, you should have 1 banana. Okay, so 1q in this case. Negative 4 minus 6, same side, so let's just combine those two. And then what you'll notice here is I simply need to add 10 to get my 35. And we can check that by plugging it back in, but there's our 4 answers to those problems. And you'll have a variation of these problems on your assignment and on the test. Taking a look at the very last thing we have here is solving for a specific variable. Now, I think the best way of doing this, or at least how I teach this to students, is I want you to treat the variable that we're trying to isolate like the variable, and treat all the other variables like they're numbers or constants. Okay, let me explain what I mean. Here, notice what they're doing is they want you to isolate the t. They want you to isolate the t. So we go over here, and I'm going to put a box around the t, because that is technically my variable. Everything else, the r, the p, and the I, are all simply like numbers. So if it helps, if you're not sure where to go, simply write this problem with everything else being a number. And say, well, okay, in this problem, what would we do? We'd probably multiply the 3 and the 2 and make 6 there, but we would ultimately divide by 6, or divide by 2 times 3. So all you got to do is go, well, if I did that here to get t by itself, why wouldn't it be any different over here? And so what we do is we come over here and simply say, I need to undo the multiplication of p and r. The opposite of a multiplication is division. So we're going to undo p and r. Whatever you do to one side, do the other. That's a cancellation property. And there you go. You've isolated the specific variable. There's t by itself. That was a simple interest problem. The second one here is the surface area of a cone. Well, L is the slant height of the cone. You don't have to know that. To be honest with you, I didn't even know that probably. I just found an example and made sure I knew what it was when I was talking to you. So sometimes they have meaning, sometimes they don't. Some things don't have any meaning. It could just be a formula of some sort, but these first two at least have some meaning to us. Let's take a look at this one and notice what they're trying to do is we're trying to isolate the L. So here's the L. I'm going to put a box around it because that's my variable. So here, this is a number, these are numbers, and this is all just a number. So if I rewrote it with numbers, it would look something like this. You know, and I could put maybe a 6 here or something. It would be like, well, really, we do this right here just for you to have an opportunity to see what to do. I would subtract 6. Now, what represents 6 is this stuff right here. So if I'm subtracting 6 from both sides, then wouldn't I subtract this thing that resembles the 6 up here? I would think logically, yes. And hopefully you do too. So let's take a look at that and see it in action. So what we want to do is we want to simply subtract pi r squared from both sides. Now the difference between this problem and the one in the blue is over here 4 minus 6 is negative 2. We can actually do that. Here s minus pi r squared, it doesn't have a value. I got to leave it as s minus pi r squared. They're not the same terms. So if they're not the same like terms, I cannot add or subtract them. They have to have the same last name in order to add or subtract. Now what we want to do is just like over here, we would have been here, we would have divided by 2 to get the L by itself. And so we end up getting negative 1 itself. Okay, so that was just an example. Coming over here, we do the same thing. Again, my goal is to get L by itself. So how do we go about doing that? Well, I've got to undo this multiplication of pi r. Whatever you do to one side, you've got to do to the other side. And I think that's key for our cancellation property, is this idea of doing it to the entire side. It's not just one term. That's a term, that's a term. I need to divide the entire side. This is the whole side of the equation by pi r. So make sure you do that, otherwise it'll get you the wrong answer. But now we have L by itself, and our answer is simply over here, that value right there. And take a look at the very last one here. We want to get x by itself. This is a little different. What we have is we have addition up here, but notice we have division up by 2. The x plus y is grouped. This is a grouping symbol. We talked about that when we did order of operations, that division sign is a grouping symbol. So these are already grouped together. So I've got to undo the division to get to that group. So to undo division, it would be multiplication. Okay? So we'd multiply, and whatever you do one side, you got to do the other. So we'd multiply by 2, and that would end up getting rid of that 2 on the bottom. And at this point, we're in pretty good shape. We want to get x by itself, so how do we go about doing that? Well, I've got to undo this addition of y. Simply means I subtract y from both sides. A and y are not the same last name, so I cannot subtract those two, but I can list it like that. And then I'm left with x, and there you go. There's your simplified version of that. This was section 1.3, solving equations.